Thank you, David. Okay, and so I do have a problem, which is I'm very loud, so if you start to get even better, very good. So less projection means more of me yelling, which is my natural way of talking. And Deb, I'm appointing you timekeeper, so let me know 10, 5, and cut it off. Okay, so yes, and David did a beautiful job of introducing me. In this talk, there's a high probability that I will offend everyone in the room. So how many of you are ready to be offended? Okay, good. So we're all on board. So I'll talk about the challenge of physical data management. I'll talk about how researchers behave in their native habitat. So the first part will offend all of the cyber infrastructure folks. Second part will offend all of the faculty and probably the grad students as well. And then I'll talk about a business model, and that'll offend all of the administrators. So we should be good. And I encourage you to constantly interrupt me with questions. I'm way more interesting talking to you than I am talking at you. I'm also way more interesting to me when we're having a conversation. So after all, if I can't have fun, what's the point? All right, so let's talk about the challenge here. I've got lots of data. Well, what the heck am I going to do with it? Where am I going to put it? Several years ago, the NSF sponsored a workshop at Princeton on research data lifecycle management, and the single most common question that came up over and over 2 or 3 days was, well, why can't we just go down to Walmart and buy some USB drives? So here's a picture of why you shouldn't do that. You could go to a NASCAR race with your riding lawnmower and start going around the track. Now, you're not going to win. You probably get killed, but you could do it. Just because you can doesn't make it a great idea. Okay? So now, if you've got small data, right? So this morning, Jennifer talked about anywhere from a few gigabytes up to a terabyte. If you've got small data, then you probably actually physically can manage your own data yourself, because you probably can run down to Walmart and pick up some USB drives. That's plenty of space, right? If you've got 100 gig or even a terabyte, you run down to Walmart, you get yourself 2 drives, you put the data on those 2 drives, and you're probably okay. Once you start getting above about 10 terabytes, that model starts to collapse. Because you're managing more and more of these USB drives, you don't know what you've got on them, and keeping track is going to be a nightmare. Okay? But it's dirt cheap, so I looked this up on the web about a month and a half ago. It came out to about $36 per usable terabyte per copy. So that's not too bad. And by the way, that is the mental model that researchers have for what storage should cost. What is it going to cost to buy a USB drive at Walmart? Okay? If you get to above about 10 terabytes, now you got to be thinking about something more sophisticated. So maybe you're going to buy a little box that you can put multiple disk drives in and run it as a little RAID system. So several disk drives pretending to be one big fast disk drive. Or maybe you'll just do that inside a PC that has lots of drive bays, so you don't have to buy a lot of extra equipment, but your cost is going to start to go up. So for example, and the price is still pretty similar. Again, this is about a month and a half ago when I checked these numbers. About $15,000 list price from Dell would get you a server with 12 4-terabyte drives in it. So that works out to a little under $500 per usable terabyte, under various simplifying assumptions that are close enough. On top of which, you've still got this issue of, well, I really do want to keep duplicate copies. Probably in the back of your head, you're thinking the word backup. By the way, how many of you regularly back up your laptop? Okay, of those who regularly back up your laptop, how many of you do that because you had a hard drive crash? Okay, so that's usually a trigger for people to start doing that. Also, regularly is intentionally ill-defined there. You've got to have more expertise to manage that server full of disk drives. You've got higher risk associated with that, and so on and so on. So these things are getting more complicated. Now, another option you could do is you could take your data and you could go pop it into the cloud. You could go to some metered storage vendor, and they will cheerfully sell you a service for your data. So Amazon Glacier, which is the cheapest one that I'm aware of, that doesn't make it the cheapest one, but the cheapest one that I know about is Amazon Glacier. It's a penny per gigabyte per month. How many of you think that sounds pretty reasonable? Okay, so then how much is that per terabyte per month? Huh? Yeah, 1,000 pennies, 10 bucks, right? 10 bucks per terabyte. Still sounds pretty good, right? So how much is that per year? It's 120 bucks a year. Okay, how much is that for 5 years? That's $600 over 5 years per used terabyte. In the case of the cloud things, they generally only charge you for what you consume, not for what you've booked. Okay? Google is more expensive. Microsoft is more expensive. By the way, they'll dicker with you if you've got big data sets. They'll come down a bit on price. But you can see we're way beyond USB drives from Walmart. We're way beyond the mental model that most researchers have for what storage ought to cost. But there's a bigger problem. Because the thing is that if you start to think about how much time you're going to need the data, in the olden days, you needed it really for the life of the project in most cases. But now, NSF and NIH have requirements for data management plans. They're starting to tighten the screws a little bit on how long you're going to have to keep your data. There are directives coming out of the White House about how long you're going to have to keep your data. And your VPR is probably terrified because ultimately where we seem to be heading is your research data has to be retained forever and be trivially accessible. That's where we're headed. Right? Okay, so on our current storage archive, we have about 560-ish terabytes of consumption. That's for the first copy. Most of it is dual copy, but let's not worry about that. If I dump that onto one of these systems, that 560-ish terabytes over 5 years on Google is going to cost about $340,000. On Amazon, it goes up. On Microsoft, it goes up. We're getting close to $1 million for about half a petabyte of data over 5 years. Now, yes, pricing will come down over time, so these numbers are only approximate. But the order of magnitude is not going to change. It's very, very expensive to retain data on metered systems over time. Okay? So is Moore's law going to save you? Is the fact that the price will cut in half every couple of years going to solve this problem? How many people vote yes, that'll totally do it? I don't have to worry because after 10 years it'll cost approximately nothing. Okay, how many people vote no? Okay, why not? Why won't Moore's law save you? Does the rate at which you generate data stay constant? Todd? No. Shake your head louder with your mouth. No, it does not. How quickly does your data generation rate grow? Yeah, it grows at least as fast as Moore's law, and probably faster. So no, that's not going to save you. By the way, if you're in the next generation sequencing business, instead of your data doubling every 24 months, it goes up by a factor of 10 every 16. Right? There's no possible way to keep up with that, especially not at this kind of pricing.
So let me interrupt then.
Please.
Moore's law, which I know we still have to talk about that with CPUs, does it even apply to hard drives anymore? I mean, it seems like it's stuck around 4.
It got stuck for a while. What I'm told, not in NDAs, so I can reveal this as rumor. The rumor is that the increase in drive sizes is going to pick up the pace again. Likewise, the tape cartridge sizes, they're picking up the pace again. So there was a pause, you're correct. But it's not as bad as, it is rumored that that will at least largely repair itself, okay, over the next year or two. All right, so that's a very good question. So Moore's law is not going to save you. In fact, if anything, Moore's law isn't going fast enough. Okay, so now let's talk about researchers. So now I've insulted all the cyber infrastructure people. Now let me insult all the researchers. Okay? So how do researchers behave in the wild, in their native habitat? Well, like most creatures in the wild, they have territoriality. They're very concerned about husbanding very scarce resources. And until recently, the data management strategy was, I'm leaving it to my grad students. Okay? So why is it that researchers prefer to hug their toys? Well, the answer is they've got no faith at all in people like me and David. No faith whatsoever. And the reason they have no faith whatsoever in people like me and David is their experience, or the experience they've heard about from their colleagues, suggests that people like me and David can't be trusted. People like me and David, we're some distant monolith where we faceless bureaucrats are making decisions entirely for our own convenience that are guaranteed to wreck your research program, right? How many of you feel that way about your administration? Okay, how many of you don't want to admit that you feel that way about? Okay, right, so, and by the way, this lack of trust as a general rule is at least partially justifiable. I'm not poo-pooing the fact that this does happen to people all the time. And the longer you've been at the game, the more skeptical and cynical you've become. That's fairly natural. So asking you now, after 20 years of hugging your toys, to let go, that's an awful lot to ask you. Okay? Affordability. Again, the mental model for what storage should cost is USB drives from Walmart. If it's more expensive than that, you're going to feel ill-used. You're going to feel ripped off, right? And this goes back to the mindset. And I think I have a slide. I don't. Okay. How many of you have one of these? Okay. 5 years ago, I used to say that our typical new user at the Supercomputing Center came from a Windows desktop background, but those were the happy days. Those days are gone. The typical user today comes to us from an iOS or Android background. This means that the mental model for storage is, I pop in a little card that's this big and costs 20 bucks. The mental model for how software gets deployed is, I tap something that gets me to the store, I search for the application I want, or the category, I tap 3 more times, right, once to find it, once to agree that Apple or Android can listen in on your phone calls, and once to actually install it. And then it's done. I never have to worry about it again. Well, maybe once in a while it'll ask me for permission to listen in on my other calls, but for the most part, I never have to worry about that software again. The way that I interact with the system is I'm just tapping the screen. It's all very straightforward. Offering that at the high end is incredibly difficult, incredibly expensive, and no one is willing to pay for it. The federal research funding agencies do not pay for good software. They pay for groovy new science discoveries, right? Any money spent on good software is money wasted from the perspective of the funding agencies. Oh, I get to insult the funding agency. Is Fan still here? Okay. So when you get to the big scale, now you're not thinking about things like, where am I going to put this big storage that I bought? Because I can't put it under my grad student's desk anymore. That's not practical. It's too big, too loud, and too hot. Right? I actually have to have something professional. I've got to put it in a data center. Data centers cost money. Right? Yes?
So you were talking about how it's not tap, tap, tap because it's
right.
very expensive, right? And so why has industry not stepped in and done that?
Because within the context of research, most research communities are tiny. And that means they'd have to make a very large fixed investment per tiny community. It's incredibly hard to get your money back out, right? It's very, very expensive to develop software, but it's roughly a fixed cost. If you've got 1 million customers, you're golden. If you've got 10 customers, you're fired.
So is that going to change?
No.
Right? Because, I mean, I would think that the number of users of high-performance computing is going to go,
Oh, it's gone up.
right?
But that doesn't necessarily mean that we have larger communities of interest in a particular piece of software. It means we have more different communities. There's more bifurcation. You've got finer and finer grained sub-disciplines with different software needs. So no, you still haven't seen significant change here. And the history suggests you never will. Okay? This problem does not get better over time, it gets worse. Okay. Maintenance gets to be very costly. Who's going to pay for it? Right? When you buy a USB drive at Walmart, if it breaks, what do? You throw it away and get another one, because when you get the next one, it's cheaper. But if you've got a petabyte storage system and it breaks, what do? You go beg somebody in the administration for $50,000 to pay somebody else to fix it. Or you paid for maintenance up front, or have some ongoing year-by-year deal with somebody to pay your annual maintenance. And your annual maintenance is not cheap. Your annual maintenance is running 5 or even 6 figures a year. Right? Okay. Historically, the data management strategy was, my data lives on my grad student's hard drive, single hard drive, in the PC under their desk. When they graduate, in the literal sense, I still have the data, but I don't know where it is. I don't know what the format is. I don't know how to read it. So they might as well have deleted it. For all I know, they filled up that hard drive with videos of their kids. And in fact, they might as well have, for all the value I'm going to get out of the data that they generated. Right? Now, again, I'm grossly over-exaggerating, but to first order, this is how things historically have been. The NSF and the NIH, and we can bet the other funding agencies are going to start doing this, they're no longer willing to put up with that. So now at least you have to say what your plan is. Or if you don't have a plan, you have to say why you don't need one. Right? But we're moving toward an era, again, where every piece of data that you generate under public funds has to be maintained over the long term and made available to the public at no more than incremental cost. Right? So they can send you a USB drive and you fill it up with the data that they say they want, which means you better know where it is. And you better have it. Okay. I've already talked about this. We don't think of labor as expensive in the research world. Why not? Because graduate students are cheap. Graduate students typically going to make somewhere between $15,000 and $30,000 a year, and their benefits, the benefits percentage is usually low, on the order of 10%. If you throw in tuition or whatever it is your institution covers, it might grow to 25%, but that's still on the order of half of what you pay for a full-time staff person. And there's no incentive to do any of this, because after all, as a faculty member, your incentives are publish papers, bring in grant money, and graduate students. Anything that you're doing that isn't those, you're implicitly going to be punished for in the sense of not being rewarded if you had instead done those things. Right? So if I spend a lot of money on storage, on a high-quality enterprise-class storage system, I'm costing myself a whole herd of grad students that would have gotten me that named professorship. Okay? All right. So the bad news is there is no way to do large-scale storage cheaper than USB drives at Walmart. There is a way to make it seem cheaper. The way you make it seem cheaper is by distributing the costs among multiple entities. So when you, as a faculty member, go to Walmart and buy those USB drives, you pay the full cost, right? You even pay indirect cost on top of that, right? It's under $5,000. It's not permanent equipment. When you've got an enterprise class system, all of those extra costs are bigger and bigger. If you can split those costs so that the researcher only pays a portion, then the researcher can be happy because they can pay at a rate commensurate with USB drives from Walmart. Okay. By the way, I'm not picking on Walmart. They just happen to be down the road from me at home. So, and I have bought a USB drive from them, although happily not for research. Okay. So let's talk about what we've done. Okay. The business model we've got at OU is this. There are 3 inputs financially. Input number 1 is a grant from the NSF. We got a major research instrumentation grant to build a storage system. Input number 2, so that grant, by the way, pays for hardware, software, and the first 3 years of maintenance on the system. And we threw in some media as well, but for the most part, hardware, software maintenance. The institution committed to space, power, cooling. We had already built a new data center anyway, so that was easy. There's actually no incremental cost to the institution in that sense, because the data center isn't full yet. So that stuff's going idle, so might as well fill it. Labor, so the institution hired someone full-time, where their initial 3 years of salary are cost share into the grant, because the Major Research Instrumentation Program requires 30% cost share. 30% of total project cost be cost share, so 30 versus 70. And then the researcher, and then maintenance after the end of the project period, so after the 3 years. So the CIO has already paid the 4th year of maintenance. The grant paid years 1, 2, and 3. And the researchers just pay for the media. So at the time we were offering they could buy disk drives. That's sort of come to an end. But they buy tape cartridges. And tape cartridges, as it turns out, are dirt cheap. So LTO5, which is what we're currently supporting, is running $27 per cartridge. It's about 1.5 terabytes. We tell people to budget for getting that about 85% full. Most of the time we can actually fill it, and in fact overfill it via compression, but think of it as you're only going to get 85% when you're budgeting. Okay. At that point, so we're getting down to about $20 per usable terabyte. At that point, it's actually cheaper than a USB drive. So cheaper than the mental model that faculty use for the expected cost of storage, that's something we can sell. The institution pays essentially a fixed cost. The NSF totally paid a fixed cost because they gave us a grant with a fixed amount of money on it. And the researchers pay the incremental cost, but that incremental cost is manageable, and in fact, it's less than they were expecting. Okay? So comparing that to the USB drives, it's cheaper, it's more reliable because it's now affordable to keep multiple copies, it's less labor, there's a minimal amount of training that's needed, and it's actually faster once it gets going. Now, there's a much longer lag, typically 30 to 60 seconds lag before the data starts drawing down from tape. But once it gets going, it's actually about 4 times as fast in terms of bandwidth. Okay. There we go. Okay. So the strategy then is distribute the costs among multiple entities. Archive. This is not live storage, right? This is not to be used for runs. This is a place where you park your data for the long term. It's your data graveyard, essentially. And what people have discovered over decades now is that once you've archived a data set, the likelihood of you pulling it back for additional analysis is low. About 5 to 10% of archived files ever get retrieved, right? But you have to keep it in case it's needed. Okay? You've got an independent standalone system. It's not part of any compute resource. It's a standalone system, so compute resources can evolve, but the system can continue. We spent the grant funds on lots and lots of slots for you to stick your tape cartridges into, but very few tape cartridges. We literally bought 100 tape cartridges total. And that was mostly just so we could get the system configured and up and running. We needed enough to do testing with. And now actually a significant fraction of them are used to back up the data catalog, the file catalog that figures out which tape cartridges various files are on. Okay? We just make everything available first come, first serve. That hasn't been a problem to date. The software cost we had to keep pretty minimal. That can grow out of control very quickly. We make it available to everybody in the state under a statewide initiative that we have. And we want to maximize the lifetime of the tape cartridge you buy. If you buy a tape cartridge in the last year of the life of the current system, how are you going to feel if I throw it away a year later? How many of you will be delighted with that? How many of you are going to be mad? Okay, of course you'll be mad. So I'd better have a strategy for that. I'm going to skip over the details of the grant here. Blah, blah, blah. You already kind of know all about this. So we're going to hit end of life around 2017. We're submitting a new proposal in 2016. We actually may be accelerating that a little bit, but I'm not going to go into details about that. If you've bought media, our goal is you still get your money's worth. So how are we going to do that? The second generation system is going to have to be backward compatible with the first generation system in the sense of being able to read and write the old cartridges. Now, that doesn't mean that we're going to be able to just pull the cartridges out and stick them in the new system, because they may use totally different software. But we can spend a year copying the old one into the new one, as long as we can then transfer the emptied out cartridges from the old one to the new one, and everybody ends up with the capacity that they had already paid for. So you may not literally be on the same tape cartridges that you bought, which, by the way, is already true, as it turns out. But you'll get the amount of capacity that you bought at no incremental charge for the life of not the first system, but its successor, the second system. Okay? The reason we can do this, LTO, which is the format of tape we're using, has a rated lifetime of 15 years, or 5,000 load-unloads into a tape drive, or 200 complete read-writes of the entire tape. We've done some examination of the tapes that we currently have, and we've been running this thing for about 3 years now. And it turns out that literally 6 tape cartridges are in danger of wearing out before the 15 years runs out. So we're not worried about losing the tape cartridges. Now, a question that came up earlier is, well, aren't you worried about losing the data off the tapes, because tape over time, you know, it sort of degrades because it's magnetic and yada, 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 right? How many of you are aware of this, that magnetic media degrade? So here's the good news. It is true that magnetic media degrade, and it is true that in the olden days, tape degraded worse than disk. But those days are over. Now, in fact, it's the opposite. Tape is, I'm not making this up, 1,000 times more reliable than those USB drives from Walmart, and 100 times more reliable than enterprise-class disk drives. So we can run them for, I'm using 10 years as the target here, not 15, but we can run them for 10 years. At the end of 10 years, under various simplifying assumptions about Moore's law and about inflation and so on, it turns out that the cost of buying new media to replace the old media is about 10% of what you originally paid. So if you pay $100 today for a bunch of tape cartridges, 10 years from now, when you need to replace them, you'll pay $10 for the same capacity. So that's affordable. After 10 years, you can make a decision. Either I want to throw the data away, or I want to find 10% of what I originally paid for a new home for the data. That's not a terrible burden. And the next 10 years later, it's 1% of what you originally paid. It's round-off error. 10 minutes. Oh, wow, OK. I'm actually, I think, right on schedule. So we have to make sure that we have a couple of drives that can handle the old media in the new system, but then the rest of the drives can be focused on the new media that are going to come in for new purchases for new data sets from the researchers. So, by the way, this is purely experimental. In fact, at the moment, it's purely theoretical. We have not proved that this works. We won't have an opportunity to prove that it works until roughly 2017. But I'm feeling pretty good about it. And the reason I'm feeling pretty good about it is I talk to people who do this for a living, full scale, and they like this idea. The trick is to make sure that you actually do get the grant. Oh, and I'm out of material, so now ask me questions. I love questions. So thank you to various people